try it anyway. Now, a particle is projected down an inclined plane. So, first thing, suppose I'll draw it this way. So we're getting projected down the inclined plane. Keyword down. Okay, speed u. Line of projection makes an angle alpha with the plane. With the plane, keyword, not with the horizontal. Okay. Well, the plane makes an angle beta with the horizontal. Show that the range R. So we're looking for a range. Okay, so we have make your four equations, find the range, and then don't worry about anything else until you get there. All right. So the rest of this question currently doesn't exist. I'm only concentrating on the purple part, all right? So don't get bogged down on anything else. Now, let's do our equation. So there's our thrown angle. And then we got dot, and we drop down here. No better. So this is going to be u. And that means that this is going to be u, that's alpha. It's going to be the usual u cos alpha and u sine alpha. U cos alpha, u sine alpha. Okay? Standard. Next thing we're going to do is the gravity triangle. I'll do it in green. Now, draw it down until it's level. And the angle here is always the same as the plane. So that's B, which makes that B, makes that G, makes that G cos B, and makes this one G sine B. So far? Alrighty. Next thing we're going to do is our four equations. So phi x is being accelerated downhill. So it's getting a boost from G sine B. So you gotta make sure that's positive, okay? So it's U cos alpha. Spell cos correctly. U cos alpha plus GT sine B. Double check, we're good. Phi y then is U sine alpha minus GT cos B. And yep. Now just gotta add on stuff. UT cos alpha plus a half GT squared sine B. Uy is UT sine alpha minus a half GT squared cos B, sorry. Exactly what you do it. So this is actually Sx and Sy. And there's always a mistake. That's the worst thing about it. There's always something. I would have spotted it eventually, but yeah, there's something. It's Sx and Sy. And the right hand sides are perfect. Is that right? Thank you. Case in point, lads. Okay. Now, let's begin. We want the range, don't we? So Sy equals 0. Can I ask you a question? Do you remember we used to get Vy equals 0? Find the time to get there and double it. Is that allowed anymore? Why is it not allowed anymore? Yeah, it's not symmetrical anymore. You only allowed to do that on horizontal grounds. Do not do that on an inclined plane. So if you want the time of flight, or you have to go to the end, Sy equals 0. Okay, let's try Sy equals 0. So we're going to get a ut sine alpha. We're going to bring the half gt squared over the other side. Half gt squared beta. Now, we're going to cross multiply. So we should get and cross off the t. So we're going to get 2u sine alpha divided by g cos beta. And that equals time of flight. I'm now going to lob the time of flight into the Sx formula. It's going to make something fairly fairly hefty that we won't like. So it's going to be U. There's the t value there. Cos alpha there. Plus a half G. Now we're going to have to square the t and then put this on B. So this is 2U sine alpha. Yep. Cos beta. And then see where we're going with this. And then it's going to be 2U. I'll square everything, sorry. Square everything and we get 4U squared sine squared alpha all over. G squared cos squared. Go with that? Alright, what can disappear here? Not much. Only the G's, is that right? Now, we're going to go down here. We're going to get Sx equals 2U squared sine alpha cos alpha over G cos B. And then on the other side, we're going to have 4 divided by 2 is 2U squared. I'm going to write sine alpha as sine squared alpha as sine alpha, sine beta, if that's okay with you guys. Now, what's on the bottom there? G cos squared beta, which is G cos beta, cos beta. What would be a really advisable move to begin with? Alright. Most people from your previous questions were used to turning stuff into tan betas, aren't we? Let's look at the answer and see if it backs it up. I don't see a single tan beta. So that would rule that idea out. But it's a good idea. I'd have the same idea. Okay, so that answer is ruled out by the no presence of any tans in the answer. Go back, go fish. What else? Do they have a common denominator? So that would be a good first move. So how do I get them a common denominator? Cos beta top and bottom, right? Now, everybody open up page 14 of your maths tables. You're going to be met with some delightful stuff. Next thing, I'm going to factorize out stuff that they have in common. Yoink. Yoink. Alright, good news. Everybody happy with me factorizing out these parts here? It's in the answer, isn't it? Factorize out those parts. So I'm going to do exactly that with one issue. I'm also taking out that sine alpha as well. Okay? So what's my next line look like? 2U squared sine alpha over G cos squared beta. That's good news. But what do we have extra? We have a 2 and a sine alpha extra, don't we? Would everybody agree with that? I took out a 2 and a sine alpha extra. So we got to keep an eye on that. And we'll have to figure out a way to get rid of it later on. Now what's left down here? Sine alpha, cos beta, and then plus what'd you say? Oh, sorry, cos alpha, cos beta. Thank God. Because I know there wasn't a formula for what I had written down, so I already knew I was wrong. I was a step or two ahead and I realized it didn't work. Now, can anybody on page 14 of your trig, can anybody find this pattern anywhere on your page? Go fish. So, Connor sees something called cos A minus B. So, you get to replace that with cos A minus B. So you end up with 2U squared sine alpha over G cos squared B, and you end up with what you say, cos alpha minus A minus B. All right. Now, the fun one. This is the really difficult one. Still haven't found what I'm looking for, have I? Still haven't found what I'm looking for. All right, I haven't. It is the really difficult one. You'd only know this if you did it previously. All right. Would anybody be so nice as to find a formula for this? What is it? It's sine x plus cos x. All right, I think I have it. Fine. Right, ready for this? On the top of page 15. Now, the only reason I know I have to change it is I'm seeing this here, and I'm going, how on God's green earth do I get that? I don't know, right? So that yellow part there is equivalent to this yellow part here. It's the only thing they have different to each other. So I'm looking for a reason to change this yellow part into the previous yellow part. How do we do it, all right? So I'm thinking, okay, what I'm looking for is 2 sine A cos B. Is there any rule for that on the top of page 15? Equals sine what? And plus or minus sine A minus B. Now, see the way I used A and B? That's problematic for me because they already have alpha and beta, don't they? They're different letters. Do you get what I'm saying? That could be x and y, and that could be x plus y, and that could be x minus y. Now in this case, what's x equal to? X equals alpha, and y equals no. Y actually equals alpha minus beta. Is that what you said? All right. Everybody see that? 2 sine x cos y. In this case, x is alpha and y is alpha minus beta. Right, I want you to apply the rule for me now. So the first one is add the angles together. So what happens when you add the two angles together? Sine 2 alpha minus beta. And what happens when you take the two angles away from each other? What's alpha take away alpha minus beta? Just beta. Is that exactly what we were looking for? It is, isn't it? So I've exchanged this yellow part here has been exchanged for this yellow part here. Direct exchange. Slot it into your answer. You're good to go. Once again, guys, you guys haven't done trig yet, so I'm not going to pull something like that at Christmas or that. That wouldn't be ideal. Might as well do it while we're here. So it's going to be u squared over g cos squared beta, and then in here it's going to be sine, what's it, 2 alpha minus beta, and then beta. And we're done. Cool? Alright. But then you realize you're not done. Because you have to do this. which is not fun either. So we'll do that in a second. Alright. I'll go with that. Now. My advice would be to go over that again sometime in the future. So I'd put an asterisk beside this question and say, do this again before your summer test. Okay? Now, next thing. I can rub out everything I just did, which I'm pretty happy about, because all I need to do is use the answer in parts. All I need to use is this answer here. And once I have this answer here, I can try and use that for the rest of the questions. Okay? So, alright. So, R equals u squared g cos squared beta into 2 sine 2 alpha minus beta plus sine beta. Okay, there's actually a hint here. See what it does to alpha? Ever see what it does to alpha? What would be the effect of doing that when you put it in here? What's the effect? Let's try it out. 2 times beta plus 90 over 2 minus beta. What's the effect? It turns it into sine 90. What's the effect of sine 90? Sine 90 is the maximum value of sine you can have. And by maximizing this value here, you maximize the range. Does everybody see that? The only adjustable part of your equation is alpha. Why is alpha the only adjustable part of your equation? It's the angle you throw at. The angle you throw at is a choice. The plane you're on isn't. You're not going to drill in and shave down your plane to make a new angle. You're better off to throw it differently. Okay? So alpha is the only adjustable part possible. So you've got to look at sine alpha minus beta, and this is how you'd figure it out. You won't always be given this in a test. You won't be given that in a test. You'll be asked to figure out what is the maximum. And here's how I'd find the maximum. I say max when it equals sine 90. This implies 2 alpha minus beta equals 90. Implies 2 alpha equals beta plus 90. And then therefore alpha equals beta plus 90 over 2. You don't have to be given that. Okay? Now as discussed earlier, sneaky, very sneaky. Alright, better show you something else. Now, what effectively happens to this angle here in yellow? What does it become? We already discussed it. It becomes sine 90, and when it becomes sine 90, it becomes 1. I'm going to change that with a 1 right now. Okay, and here's where the other sneaky part of the trick comes in. Alright, compare what I have to the answer they have. What did they have differently? They have no 1 plus sine b, do they? And they have a 1 minus sine b on the bottom, okay? What did they get rid of? What's not there? Cos squared beta disappeared. How did it disappear? It's a different matter. So here we go. There's a rule I got you to learn off in chapter 3. The rule is cos squared a plus sine squared a equals 1. Cos squared any angle plus sine squared the same angle equals 1, no matter what angle you pick. Now, we're going to get rid of cos squared alpha, so we're going to get rid of cos squared beta. Okay, so I'm going to change these to betas, or b's. Now, would everybody agree it's 1 minus sine squared big? What is 1 minus sine squared big? The difference between 2 squares. There you go. Once again, only because I've seen it a couple of times before, I'm aware of it. Okay, then what do we do here? R equals u squared over g 1 plus sine beta 1 minus sine beta, and then on top is a 1 plus sine beta, and thank you very much. Bam, bam. There's your answer. Okay, so the answer is u squared over g 1. Very different. Okay. Next thing, if b equals 20 degrees, find the value of a. No bother. And I take it this is for a maximum range. Alright. So, the next part's really easy. So all you need to do is put in 20 up here. So 20 plus 90 divided by 2. 55 degrees, yeah. And if beta equals 0, where it's a flat plane. If beta equals 0, it means there's no plane, which means you're effectively throwing on flat ground. And when you throw a flat ground, it's always a 45-degree angle that gives you the greatest pitch. So when b equals 0, it's going to be 0 plus 90 over 2 equals 45 degrees. Alright, done. That took 20 minutes.